Hello, it's Joseph, and in this video, I'm going to show you how I added light and sound effects to this 3D printed replica of a DC-17 blaster. So after I finished my build for my NeoPixel lightsaber using the CFX module, I decided that I wanted to add a DC-17 blaster to my collection. It's one of my favorite blaster designs from Star Wars. And I'm also kind of envisioning myself as a Jedi character who's taken the blaster from one of the ARC troopers while I was escaping Order 66. But ultimately, the choice to use the BlasterCoreV.5 sound module occurred after I watched a video from Rob Pepko at Genesis Custom Sabers, where he uses the BlasterCoreV.5 in a modified Nerf rifle. It's pretty cool, and you should definitely check it out. Finding a replica of the DC-17 took some time, but I eventually stumbled across this one from Etsy. After I purchased it, it took about 2 to 3 weeks to arrive. The design is by Jetstorm477, who also has the model available for download on Thingiverse for free. To do this, of course, would require a 3D printer, which I did not have at the time I purchased the blaster from Etsy. If you do have a 3D printer and want to download the free files from Thingiverse, please be sure to make a donation to Jetstorm to show your support of his work. He also has a link to a YouTube video on his Thingiverse page where he shows you how to assemble the pieces. Now, Jetstorm477's original design was meant for a 22mm speaker, a single 5mm LED, 3 AAA batteries, and a switch. I, of course, just had to go bigger than that. I really wanted to max out the potential of my BlasterCoreV.5, which I had purchased from the Custom Saber shop, by the way. For this installation, I added an 18650 rechargeable lithium-ion battery, a 28mm bass speaker, 17 5mm RGB LEDs, and various switches. So I was definitely cramming a lot of things into this little blaster. Here's the process that I took. I first began my focus on wiring the board. Here is a diagram of my wiring, which I will link in the description if you too would like to purchase a blaster core for your project. Before wiring the board, I traced the outside of the 3D printed model on a piece of plywood to give me some idea of how much internal space I was working with. This helped when cutting my wire to the necessary length. I started soldering the recharge port. This allows me to cut power to the board with a kill key, which is my preference for saving battery life. Just like in my lightsaber video, the center peg only goes to the battery negative. The peg clockwise from the battery negative will go to the board negative pad, as well as the negatives for all 12 of the energy bar LEDs, which I will discuss those later in the video. The peg counterclockwise from the battery negative goes to the board positive pad and the battery positive connection. I also applied a JST connector so that in the future I can easily replace the battery at the end of its lifespan. I then soldered the recharge port to the BlasterCore module and then soldered the connections to my 28mm speaker. This allowed me to briefly test the speaker. Next, I soldered the wires for the main LED, which will simulate the flash coming out of the barrel of the blaster. The way you see me wiring this to the board will allow me to make use of both the red and blue colors on the LED. So I can program the board to have the LED flash red for kill, and then have the LED flash blue when I switch to stun. Then came the process of wiring the connections for the energy bar PLI LEDs. These blue wires will go to 12 5mm LEDs, which I will use as an energy display on the side of the blaster. I'll show this later in the video, so stick around. The red wires will go to auxiliary flash LEDs. These LEDs will face out on the sides of the barrel of the blaster and give the illusion of energy traveling down the barrel of the blaster. They can be programmed to flash slightly before the main LED. The way I have them wired also allows me to program them to match the main flash when it is set to red for kill or blue for stun. I was going to use SMD resistors on these pads, but they were slightly too large. So what I decided to do was just go ahead and bridge them and use inline resistors later on in the wire chain. After that came the soldering for the switches. I used this momentary lever switch for the trigger. I had to make sure to solder the negative wire to the normally on or NO connection. Jetstorm designed the 3D printed model specifically for this type of switch and has a housing for it that fits perfectly. The switch just fits behind the trigger, and then I just used a spring from a pin and placed that behind the trigger, and there's actually a little hole inside the model that allows for the spring, and that allows the spring to kick back when it is not pressing down the switch. Next, I wired these two tactile switches. One of the tactile switches is used as an auxiliary for changing the power level on the blaster and accessing the menu functions. The other tactile switch was meant for the cycling of the settings on the LED display. However, the OLED I purchased was not compatible with the BlasterCore module, but I went on ahead and installed the switch anyway because I just didn't feel like removing it. The second limiting switch that I wired serves as the clip-in out switch. In other words, I can use it to trigger sound effects that make it sound like I'm removing a clip from the blaster. When the switch is open, the board will not allow you to fire the blaster until you close the switch or put the clip back in. This one also required me to solder the negative wire to the NO negative. The final switch is a 16mm anti-vandal latching switch with a green ring LED. This latching switch will allow me to access the semi-automatic and automatic firing system on the BlasterCore module. Now, why do I need automatic fire from a blaster pistol? I don't know, it just seemed like a cool feature, and like I said earlier, I wanted to max out the BlasterCore's abilities with this build. With all the switches and wiring attached to the board, I removed the kill key and did a few tests before moving on to the next step. I then moved on to wiring my main LED and auxiliary flash LEDs. I still had several 5mm RGB LEDs left over for my lightsaber project. However, I failed to notice that the BlasterCore manual says that I need to use common anode LEDs for the main flash and auxiliaries. The LEDs that I already had were common cathode. So I had to make a purchase on Amazon for common anode LEDs, but that was a pretty simple adjustment to make. Remember, read the manual thoroughly. I originally wired 6 auxiliary LEDs, which makes 3 for either side of the barrel. However, as you will see later in the video, I could only get 4 to fit into the blaster. Each LED on the left side shared the same negative and positive lines with its counterpart on the right. With the main and auxiliary LEDs wired to the board, it was time for another test. After pulling the kill key to boot the blaster, you can see me opening and closing the clip-in out switch, which triggers sounds that sound like you reloading the blaster. When you press the main trigger switch, the blast sounds will trigger and the main and auxiliary lights will light up. Since this is a kill setting, they are flashing red. Eventually, the blaster simulates running out of ammo, and you have to long press the auxiliary switch or open and close the clip-in-out switch to keep firing. When the 16mm anti-vandal latching switch is pressed, the green ring LED lights up to show you that you are in full automatic mode. Then you can press and hold the trigger switch to simulate automatic fire. There are 5 kill power level settings that you can cycle through with the auxiliary switch and 1 stun setting level. When the blaster is set to stun, the blue on the main LED and auxiliary LEDs will light up instead. Now, before I could move on to installation step, I had to prepare the 3D model for this ridiculous amount of material. I carefully measured out where I wanted to place the battery, the speaker, the switches, the LEDs, and of course I took a few notes on this. Remember the old axiom, measure twice and drill once. Or in my case, measure a lot and then pray you drill it right. I then moved on to drilling a hole for the recharge port on this knob piece on the back of the blaster. Just as I did when I drilled holes for the switches in my lightsaber build, I started with my smallest drill bits and I worked my way up until I had a hole that was slightly bigger than the threading on the recharge port. I had to be careful not to drill at too high of an RPM since I was working with plastic. And by the way, every hole I drilled in this step was so stressful. I was really worried about cracking the plastic. So after that, I did a lot of Dremel work. Jetstorm 477's design was not meant for my battery, and the space he designed in the handle was just not large enough for it to go there either. So I dremeled out space in the main section of the blaster for the battery and the speaker. Oh, by the way, the battery you see on screen was not appropriate for the BlasterCore version 5, but I'll explain later, so keep watching. The more space I dremeled out of the blaster to fit all these components, the more my heart broke just a little every single time. I genuinely felt that I was destroying Jetstorm's amazing model as I was in the process, but I pressed on despite this. Jetstorm, if you end up watching this, I'm so sorry. After making space for the battery and speaker, I then moved to the upper part of the blaster and cut an opening on either side. Eventually, I would put the energy bar LEDs here. In the barrel section, I drilled small 3mm holes for the auxiliary LEDs to shine through, and I also drilled holes that would allow sound from the speaker to come through. It was really hard to avoid cracking the plastic on this drilling part of the build, but somehow I was able to get through this without doing that. I then moved on to drilling a hole for the 16mm anti-vandal switch and some small holes for the tactile switch. I recessed the hole for the anti-vandal switch with my step drill. Next came the installation of the energy bar LEDs. I needed a way to diffuse the light coming from the LEDs, so I just cut off a bit of these panels we have in our kitchen. I can't remember if I told my wife about this or not, but it's definitely public information now. To be honest, I did make sure to cut where it wouldn't be noticeable to house guests when I reinstalled the panels. After cutting and shaping the diffusion panel pieces, I superglued them over the openings I made in the blaster. I honestly had no clue what type of plastic I was working with, so I didn't know how the superglue would react to the panels. It turned out that the reaction fogged up the effect, and ultimately, though, this worked out and actually made the diffusion a little more effective. However, it is always best to make sure beforehand that you check out what kind of plastic you're using and make sure that it is compatible with whatever superglue you're using, especially if you want to avoid this sort of fogging effect that can happen in the plastic. Now, unlike the main flash and auxiliary flash LEDs, these 12 LEDs that I installed as the energy bar were common cathode RGB LEDs. Even though I only used the blue light on the LEDs, I felt they were just going to go to waste if I didn't use them for something. If you do this yourself, you may want to just purchase a single color LED. The BlasterCore does not give you the option to wire up all three of the colors on an RGB LED for this energy bar. You can only pick one color. Like with the auxiliary LEDs on the barrel, all these energy bar LEDs on the left share the same positive with their counterpart on the right, and all 12 of the LEDs shared the same negative wire, which went all the way back to the recharge port. Now, when I installed the LEDs behind the diffusion panel, I just had to use some hot glue to hold them in place. Then came the hardest part of the entire build, which was cramming all of this stuff in this small blaster. Now, if I had chosen a rifle like Rob Petkow had done in his video that inspired me to do this project, this step would of course been a lot easier, but I just had to challenge myself on my first blaster project. Couldn't do it easy for some reason. The main issue I ran into, besides finding space for all of this wire, was getting the tactile switches to not, break their solder points whenever I tried to hot glue them in place. I had to remove them several times and resolder them and then restart the installation, and I really couldn't move on until those switches were in their place. Thankfully, I was smart enough to use hot glue instead of super glue to hold the auxiliary switches in place. If I had used super glue, I'm pretty sure I would have ruined this project on this step. It was during this process of cramming everything into the blaster when I noticed this problem. Oh boy, something was definitely wrong with the sound. So, I contacted Irv Plecter, the designer of the BlasterCore and CFX sound modules. With his help, we determined that the issue was with the speaker amplifier. Irv then gave me the manufacturing model, and I ordered a replacement from Texas Instruments. The manual for the BlasterCore states that the speaker amplifier needs somewhere between 5 to 11 volts to operate properly, so my theory is that I broke my amplifier by using a 3.7 volt battery, as this could have increased the ohm resistance running through the amplifier. I'm not 100% sure if this is what happened, but once I had installed the replacement amplifier, I then began using a 7.4 volt 14500 lithium ion battery instead of the 3.7 volt 18650. I've had no issues with the amplifier since doing this. With the speaker amplifier replaced, it was once again time to try and install everything. With the main trigger switch and auxiliary switches installed, I then ran all the wire through the handle of the blaster and out through the top. This of course meant I had to remove the speakers and the recharge port from the board first, but once all the wire was through the handle, I just resoldered those connections back to the board. The recharge port was then installed into the knob piece and was fixed into place with a small nut provided by the custom saber shop. I purposefully purchased a black kill key to help it blend in with the blaster. Then came the installation of the main and auxiliary LEDs. I had to detach the main LED and run the wires through its hole before reattaching the LED to the wires. Now, Jetstorm 477 had designed the model for this main LED to actually rest inside of the blaster, but I decided to super glue it to the outside so that there was a little bit more room for the auxiliary LEDs. Each of the auxiliary LEDs was hot glued into place. I had originally wanted 2 speakers wired in parallel for the blaster, but I had to settle for one because of all the space needed for the wire and the battery. Next, I soldered the wires to the 16mm anti-vandal latching switch and then crammed it into its space. Next, I superglued the clip-in out momentary switch to the inside of the handle with the lever exposed. This crafting foam, which I had purchased for the lightsaber project, came in pretty handy. I glued it on the inside of the clip piece so that when it was attached to the bottom of the blaster, it would close the switch. I made sure to place the momentary switch in a location that still allowed me to get to the SD card in the BlasterCore sound module located on the inside of the handle, so that way I can remove it for making edits to the LED lights and adding more sound fonts. It was then finally time to connect the energy bar LEDs to the board. Each of the LEDs required a 35 ohm quarter watt resistor. Since I did not attach SMD resistors to the board, I had to use inline resistors. I knew ahead of time that this was a bad idea, as the inline resistors took up a lot of space. So if I were to do this project over again, I would definitely make sure to install SMD resistors on the board instead. Unfortunately, despite all of my efforts, there was still not enough room to cram all of this wire and material into the model. So once again, I had to get out my Dremel and carve out more space. I even removed the triangle piece that protected the trigger. But eventually, I was able to get everything inside, and I used an M4 screw and nut, which I purchased from a local hardware store, to lock everything in place. Then, all that was left was to super glue the side pieces of the blaster. Well, I hope you enjoyed watching me add these light and sound effects to this replica. I also wanted to take a moment to show you how it all works. First off, we start by pulling the kill key, and that creates the boot sound. And then, of course, you have your energy bar graph here. Those are those 12 LEDs on both sides. Of course, you have your main trigger. And as you fire, the main LED flashes. You also will see the auxiliary LEDs here in the barrel, and they are matching the light from the flash. And you'll see the energy bar graph also reacts to pulling the trigger. So I can change the power level that is going on. There are 5 kill levels and a stun level, so 6 levels in total. So now I'm at the highest level, and as I pull the trigger, you'll notice that the energy bar depletes faster. And then when it runs out of charge, I can pull the clip. There's the little switch right here. And that goes through the reload process. Just stick it in there and it does that. This, of course, gets to the automatic fire. You can see that the green LED lights up whenever we're in full auto mode. Turn it off. Oh, and I'll show you the stun setting. See how the auxiliaries light blue now? I recognize that the DC-17 that you've probably seen in Clone Wars or in the Bad Batch is always firing blue, but don't worry, I have that in mind. This particular sound font is set up kind of, as I said earlier, is kind of my vision of my Jedi character having the blaster post-Clone Wars and the Dark Times and not really having access to the ionized Tabana gas. But I do have a more Clone Wars era theme sound font. So if you press the auxiliary and the main trigger together, press and hold them together. Got to press them again. Now we're in the sound fonts menu. So this is the more Clone Wars themed. Press and hold the auxiliary to select that sound font. And so now the kill setting is at blue. And then if I go to the sun setting, it too is at blue. Well, anyway, I had a lot of fun making this project, and I wanted to send out a couple of thank yous for some people that helped inspire this project. Once again, Rob Petkow, showing off the Blaster Core, and that kind of inspired me to get going in the process. Jetstorm 477 is the one that designed this 3D printed chassis. Make sure you check the links in the description, and if you are interested in downloading his files to use for you to, if you have a 3D printer and you want to print it off yourself, please make sure to donate to him and show your support to him as an artist. Or you can purchase off of Etsy, and I also link that down below. And that's how I got it, was by purchasing it from Etsy. I think it's one of the best blaster designs out there. It already had, the slot for the LED in mind, for the trigger, and those sorts of things. And a lot of the other stuff was, of course, me modifying his design to make it work for all the stuff I crammed in here. But ultimately, I went with his design because of some of these features that he had included in the design. I also want to take a moment to thank Irv Plecter, not only for building the BlasterCore version 5, but he was extremely, extremely helpful. If you think back to in the video and that spot where I said that there was a delay and I had to replace the regulator, he was so helpful in helping me get that problem fixed and helping me resolve that. And if Irv, you happen to be watching, again, thank you so much for your help through your emails and your support. Well, that's all I have for you guys. I hope you really enjoyed this one, and thank you for watching, and you have a pleasant day.